Welcome to Homework Lib.
For this question, we are given a chemical reaction of BF3 reacting with NH3 going to F3BNH3. And we are given 4 experimental sets of data. The data shows initial concentration and initial rate. To determine the rate law for this reaction, we need to know the order of the reaction with respect to each reactant. To determine the order with respect to ammonia, we will notice that in experiments 1 and 2, BF3 concentration stays constant, and going from experiment 2 to 1, the concentration of NH3 is doubled. So when we double the concentration of NH3, going from experiment 2 to experiment 1, we see that the rate also doubles, going from 0.0165 molar per second to 0.2130 molar per second. Because when the concentration is doubled, the rate doubles. This means that it is first order with respect to the reactant concentration that was doubled, namely ammonia. It's first order with respect to ammonia. For BF3, it's a little bit more difficult. It's hard to see a doubling that occurred with a concentration and a corresponding doubling or quadrupling or no change at all to the rate. Concentration doubled, rate doubles, first order. Concentration doubles, no rate change in rate, 0 order. Concentration doubles, rate quadruples, second order. So we have to calculate this numerically. Let's look at experiments 3 and 4. We see in experiments 3 and 4 the concentration of NH3 stays constant. This is important so we can cancel it from our calculation. The calculation is going to be a setup of 2 rate laws. The first one will be the rate from experiment 3 equals the rate constant multiplied by the concentration of BF3 in experiment 3 raised to some unknown order, unknown power, multiplied by the concentration of ammonia raised to its order, which is first order. We'll then divide that by the data from experiment 4, where the rate is 0.1193 equal to rate constant multiplied by the concentration of BF3, which is 0.350 molar, raised to some unknown order. And then we still have the concentration of 0.100 molar for ammonia raised to the first order. So we'll cancel what's common. The numerator and denominator has 0.100 raised to the first order. The numerator and the denominator has a k value. So then what we can do is we can divide these two numbers and we'll get 0.572. Set that equal to what's left, this division raised to the x, 0.0571 raised to the x, and hopefully it becomes obvious at this point that the only way that we can get this equal to each other is if x is 1. So it's first order with respect to BF3 also. However, if it's not obvious, you can take the log of both sides. This then makes the exponent a multiplier, and we end up with the log of this value divided by the log of this value equal to our exponent, which is 1. Now we know it's first order with respect to NH3 and first order with respect to BF3. So we can write the rate law as rate is equal to K multiplied by each of these concentrations raised to the first power. Next, for part B, it asks what's the overall order of the reaction. Well, because it's first order with respect to each reactant, and there's only 2 reactants, then it's second order overall. Part C asks you to calculate the rate constant with proper units. To calculate the rate constant, we simply need to know the rate law, concentrations, and a corresponding rate. We have 5 sets of data that show us concentrations and corresponding rate. So you can choose one of them or all of them and average them. I'm just going to choose the first experiment. In the first experiment, the rate is 0.2130. We'll set that equal to K multiplied by the concentrations of the reactants. They're both 0.250. Raise each of them to the first power, because they're first order. Rearrange the equation to solve for K, and we get 3.41, 1 over molarity seconds. Because it is second order overall, the K, the rate constant, for second order overall reactions is always 1 over molarity time, and the time for this one is seconds. Part D then asks, what is the rate when we have two given concentrations for the two reactants? Well, now that we know the rate constant and the rate law, so long as we know the concentrations, we can calculate the rate. So rate will be equal to the rate constant we determined, 3.41, 1 over molarity seconds, multiplied by the two concentrations that are given, 0.1 molar for BF3 and 0.5 molar for ammonia. And we get a rate under these circumstances of 0.170 molar per second.